A very good morning to all of you. Dear students, how are you all? I welcome you to this chemistry session of second year, in which I am going to teach you Unit 7 of P block elements. But before actually starting the lesson, I want you to recall what you have studied last year, periodic table. In the periodic table, you have seen the arrangement of atoms in the increasing order of their atomic numbers. You have studied about various periodic properties like atomic size, their electronic configurations you have studied, general electronic configuration of S, P, D, F. Atomic radii in the sense covalent radii, ionic radii, then you have studied. Then ionization enthalpy, electrogain enthalpy, electronegativity, metallic characters, and the variations of these atomic properties along the period and down the group you also have studied. And you have studied the reasons for certain anomalies found. Then you have studied about the classification of elements into S block, which is at the left extreme end of the periodic table, and P block at the right extreme, and D block elements in the middle of the S and P block. Then you remember F block is kept separately at the bottom of the periodic table. Then you have studied about group 1 of alkali metals and group 2 of alkaline earth metals. Then you also had a lesson P block elements, in which you have studied group 13 of boron family and group 14 of carbon family. I think you are all trying to recall what you have studied last year. That's very good. Now this year, after group 14, we have to study starting from group 15, then 16, 17, and of course group 18 of noble gases. So now we'll start with the group 15 elements. We'll start with group 15 elements. We'll see what are the different elements present in group 15. It is nitrogen, phosphorus, arsenic, antimony, and bismuth. So nitrogen, phosphorus, arsenic, antimony, and bismuth are the 5 elements present in group 15. So we will have the study in a sequence manner. First we will study about the occurrence of these elements, and then we will study some of the atomic properties, and then we will study some physical properties of these elements, and then we will see some chemical reactions with other elements, that is chemical reactivity, especially the oxidation numbers, reaction with halogen, oxygen, hydrogen, and with metals. And last we will study anomalous properties of nitrogen. Anomalous properties of nitrogen. So we will have a study in this sequence. So at the beginning we will see where do we get these elements in nature. So first we will start with nitrogen. You all know nitrogen is an abundant element in the atmosphere, nearly 78% by volume in the atmosphere. It's a colorless gas present in the atmosphere. Then nitrogen is present, or it's a very important constituent element of proteins present in plants and animals. And nitrogen is also present in the Earth's crust in the form of its minerals, nitrate minerals. For example, NaNO3 is called chili saltpeter. NaNO3 is called chili saltpeter, and potassium nitrate is called as Indian saltpeter. So these are the sources of nitrogen, and nitrogen bases also constituent the nucleic acids RNA, DNA. Then coming to phosphorus. Phosphorus is present in the Earth's crust in the form of minerals, phosphate minerals. So there is a family of the minerals called apatite family, with the formula 3Ca3PO4 twice dot CaX2, where X can be fluorine, chlorine or OH. If this is called apatite family, and if X is fluorine, if this becomes calcium fluoride along with this, it's called fluorapatite. It's called fluorapatite. Then phosphorus is present in living matter, in bone, and then phosphoproteins are present in egg, milk, etc. And phosphate linkages are present in DNA and RNA. So this is about phosphorus. Next, coming to arsenic, antimony and bismuth. These three elements are present in very small or trace quantity in the Earth's crust in the form of their sulfides. So arsenic, antimony and bismuth are present in the form of their sulfides to very trace quantities in the Earth's crust. Now after knowing the occurrence of these elements, next we will start to study some of the atomic properties. Some of the atomic properties. Now we will see the electronic configuration of these elements. We'll see electronic configuration. As you all know, in group 15, the outer electronic configuration is ns2 np3. There are 2 electrons in the s orbital of the last shell and 3 electrons in the p orbital. So altogether there are 5 electrons in the outermost shell. Now coming to nitrogen, after helium it is 2s2 2p3, it is in the second shell. Next coming to phosphorus, after neon it is 3s2 3p3. For arsenic it's argon with, but in the fourth shell we also have 3d orbital in between 4s and 4p, so I write it as 3d10 4s2 4p3. Next in this also 4d10 5s2 5p3. And in the last one, in the case of bismuth, it is after xenon we have in the sixth shell we also have f orbital, so we have to take 4f 5D10, 6S2, 6P3. So you all know all these from Pauli's principle, how to build up the electronic configuration you have studied last year. Now, in all these, you have studied last year that in a group, they have similar outer electronic configuration. So you can see here 2s2 2p3, 3s2 3p3, last shell 4s2 4p3, 5s2 5p3 and 6s2 6p3. So all of them have 5 electrons in their valence shell. Now I think all of you have recalled one thing here, looking at the 3 electrons in the p orbital. According to Hund's rule, they occupy different 3 orbitals. So the symmetric arrangement of electrons in the p orbital is exactly half filled, gives more stability to these atoms. That thing you have to remember. This is about electronic configuration. Next, we will see what happens to the atomic radius. So you already know, when we move down in a group, with the addition of extra shells from 2 to 3, 3 to 4, 5, 6. So we are adding, the principal quantum number is successively increasing by 1 unit. So the atomic radii increases as you move down. So when we move down in the group, the atomic radii goes on increasing. But from nitrogen to phosphorus, there is a big increase in the atomic radius. Then onwards, the increase is regular, not too much of increase. The reason is, in phosphorus, the S and P electrons of phosphorus yield shielding effect, because of which the electron cloud of phosphorus slightly expands. Then onwards, in the heavy, the screening effect offered by the D electrons in arsenic and antimony are imperfect, and in bismuth, F electrons offer poor shielding effect. Therefore, the size does not increase much. So the increase is not regular. So next, we will see one more atomic property called ionization enthalpy. What happens to the ionization enthalpy when you move down? So when we are moving down, since there is increase in the atomic size, removal of electron becomes easier, and therefore the energy required to remove the last most loosely bound electron from the neutral gaseous atom decreases. So as we move down, the ionization enthalpy decreases. And one more thing you have to remember here, due to the exactly half-filled configuration in the p orbital, the ionization enthalpy of group 15 elements is little more than expected, because you have to supply little more energy to break the stability. Next atomic property is electronegativity. So nitrogen is the highest electronegative element in this group, after to fluorine, then oxygen. So first is fluorine, then oxygen, then nitrogen, and the value of this in Pauling scale of nitrogen is 3.5. So nitrogen is small atom, so it's highly electronegative. But electronegativity is the capacity of an atom to attract the pair of electrons towards itself, which decreases with the increase in size, because the nucleus cannot hold the electrons which are very much away from itself. So as the size increases when you move down, the electronegativity goes on decreasing. So these are the some of the atomic properties and their variations which you have to study about group 15 elements. Next we will study some physical properties. What are the physical properties of these metals, or I am sorry, these elements. Now nitrogen, as the ionization energy goes on decreasing down the group, nitrogen, the metallic character goes on increasing, and nitrogen and phosphorus are non-metals, and the next two start getting non-metallic character, so they are metalloids, and bismuth is a typical metal. So the non-metallic character goes on decreasing down the group, and metallic character goes on increasing. So these two are non-metals, these two are metalloids, and bismuth is a metal. Then nitrogen is a gas and all the others are solids. Nitrogen is a gas and all the others are solids. And except nitrogen and bismuth, others exhibit allotropy, and boiling point and melting points always increase when you move down from the top to the bottom in any group due to the increase in the atomic mass or molecular mass, increase in the number of electrons, increases of van der Waals attraction force. Therefore, the boiling point and melting point also increase. But the melting point increases up to arsenic, then decreases owing to the loosely packed structure of atoms in its layered structure, and in bismuth it is a metallic bonding which exists. And then nitrogen exists as a diatomic molecule. Diatomic molecule with atomicity 2 with a triple bond between, 3 covalent bond between 2 nitrogen atoms, whereas all the others exist as tetraatomic molecules. These 3 exist as tetraatomic molecules, but only single bonds between them. PP, AS, AS, only single bonds. There is no triple bond or multiple bond like nitrogen in the other two. And in bismuth, it is having metallic bonding where the positive bismuth ions are embedded in a sea of mobile electrons. These are some of the physical properties about group 15 elements. Next, we will see the chemical reactivity of these elements. How do they vary in their chemical vigorness or nature when they react with the different elements? So before that, first let me take oxidation numbers. Chemical reactivity or reaction with different elements. In that, first let me consider oxidation states. What do you mean by oxidation state? It represents the number of electrons that can be either donated or accepted or shared through covalent bonds, so that an atom becomes stable with the 8 electrons in the valence shell. So ಯಾವುದೇ ಒಂದು ಪರಮಾಣು 8 ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಹೊಂದಿದಾಗ ಸ್ಟೆಬಿಲಿಟಿಯನ್ನು, ಸ್ಥಿರತೆಯನ್ನು ಪಡೆಯುವ ಕಾರಣ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನುಗಳನ್ನು ಪಡೆದುಕೊಂಡ್ರೆ ಅಥವಾ ಕೊಟ್ಟರೆ ಅಥವಾ ಹಂಚಿಕೊಂಡಾಗ ಅದಕ್ಕೆ 8 ಆಗಿ ಸ್ಟೆಬಿಲಿಟಿ ಬರುತ್ತೋ ಅದನ್ನು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅಂತ ಕರಿತೇವೆ. ಇಲ್ಲಿ ನಾರ್ಮಲಿ ದೀಸ್ ಎಕ್ಸಿಬಿಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ -3. Why -3? Because they have 5 electrons in their last shell, NH2, NP3. They need 3 more electrons, so -3, or they can share 3 electrons or 5 electrons through covalent bonds to have +3 and +5 oxidation states also. So the common oxidation state of all these elements are -3, +3 and +5. Of course, there are some anomalies observed. That is, let me talk about the negative oxidation state of -3. -3 is gaining electron. So nitrogen is a small atom, it can easily gain electron to hold it, but as you move down, with the increase in the size, the capacity of the atoms to gain electron goes on decreasing. ಸೊ ಆಟಮ್ ದೊಡ್ಡದಾದ ಹಾಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಪಡೆಯುವ ಸಾಮರ್ಥ್ಯ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗೋದ್ರಿಂದ ದ ಸ್ಟೆಬಿಲಿಟಿ ಆರ್ ಟೆಂಡೆನ್ಸಿ ಆಫ್ ದ atoms, these atoms, to exhibit -3 oxidation state goes on decreasing. So as you move down, the ability of -3 oxidation state for these elements goes on decreasing. Next we will come to +3 oxidation state, where it can share 3 electrons forming covalent bonds, or +5. Now we will see +5 what happens. When you move down, the stability of showing +5 oxidation state also decreases. What is the reason? This you have studied last year also, group 13 and 14. When you move down, the electrons present in the S2, electrons say we don't want to come for bonding, we want to keep ourselves away, we are not available for bonding. So as you move down, these 2 electrons in the heavier elements are not taking part in the reaction, they are reluctant, and therefore the tendency of these elements to exhibit +5 oxidation state goes on decreasing down the group, and therefore the tendency of +3 goes on increasing down the group. So this is about the common oxidation states. Now coming to nitrogen, nitrogen exhibits various oxidation states starting from -3, -2, -1, 0, and from +1 up to +5. -3 is in ammonia, it is in hydrazine, -1 in hydroxylamine, 0 in nitrogen and nitrous oxide, +2 in nitric oxide, +3 in nitrogen trioxide, +4 in nitrogen tetroxide, +5 in nitrogen pentoxide. So normally it exhibits positive oxidation states with the elements like oxygen, fluorine, etc., highly electronegative. So nitrogen shows a various oxidation states, and all the intermediate oxidation states of nitrogen from +1 to +4 disproportionate in acid solutions. So what do you mean by disproportionation reaction? Here the valency of the oxidation number of nitrogen is +3, and here it is +5, here it is +2. So in one product the oxidation number is increasing, and in the other product it decreases. Such reactions you have studied in redox reactions as disproportionation reaction. So this is about nitrogen, whose intermediate oxidation states from +1 to +4 normally disproportionate in acid solutions. Next, coming to phosphorus. Phosphorus also exhibits oxidation states of +1 to +4 in its oxo acids. In oxo acids, here also the intermediate oxidation states of phosphorus disproportionate to give normally phosphoric acid and phosphine with the oxidation number +5 and -3. So there also disproportionation occurs. So this is about oxidation states of group 15 elements. Next we will study the reaction with hydrogen. Reactivity with hydrogen. These elements form a compound which is covalent of the general formula EH3, where E can be nitrogen or arsenic, antimony or bismuth. So these elements form covalent hydrides of the formula EH3. Now we will see their properties. NH3, PH3, ASH3, this is called ammonia, this is called phosphine, this is called arsine, and this is called stibine, and this is called bismuthine. So we will study some of the properties of these hydrides. Now when you move from this ammonia till that end bismuthine, the bond length of EH goes on increasing. That is bond length. The NH bond is smaller, then pH bond is slightly bigger, so the bond length increases, and here the longest bond length between the metal and hydrogen is in this case. So bond length increases. Therefore, the bond dissociation enthalpy of these hydrides also decreases as you move from ammonia to bismuthine. That is, when the bond length increases, the strength of the bond decreases, it becomes easier to break the bond, so we can apply lesser and lesser amount of energy. Therefore, ammonia has a high bond enthalpy, dissociation enthalpy, and pH3 lower, so bismuthine is thermally unstable. So you can have reading till here. So the bond dissociation enthalpy goes on decreasing. And due to this, the reducing character or property, that is to provide hydrogen for a reduction, goes on increasing, because the removal of hydrogen or giving capacity of hydrogen, giving capacity of these elements increases as the bond becomes weaker, and therefore reducing character increases from ammonia to bismuthine. So ammonia is a weak reducing agent and this is a strong reducing agent. So ammonia is a weak reducing agent and that is a strong reducing agent. And due to the decrease in the bond dissociation enthalpy, their thermal stability also goes on decreasing. So the thermal stability also goes on decreasing as you move. And there is one more property of these hydrides, that is basic character. So the one more character is basic character. What do you mean by this? All these elements form 3 bonds with hydrogen using the 3 p electrons, whereas the 2 electrons are present of s orbital on these metal or elements as a lone pair. So the lone pair of electron present on these atoms make them Lewis bases, which can be donated. So these act as Lewis bases. But what about the basic nature when you move from ammonia to bismuthine? It goes on decreasing. The reason is this lone pair is present in a small orbital in a nitrogen. The electron density is very high, and when you move here, the lone pair is present in a large orbital and the electron density is less. So the electron donating capacity is less in the case of bismuth compared to ammonia. So when you move from ammonia up to bismuthine, the basic character goes on decreasing, and therefore ammonia is a strong base and this is a weak base. So these are some of the observed reactions of these elements with the hydrogen and their hydrides. Next we will see the reaction with the oxygen. How do they react with oxygen and what are their properties? So they use their +2, 3 and +5 oxidation states to give trioxide and pentoxide. For example, you can have P2O3, P2O5, phosphorus trioxide, phosphorus pentoxide, nitrogen trioxide and pentoxide. So, all these form two types of oxides, trioxides and pentoxides, in which the oxide with the higher oxidation state of the element is more acidic than the trioxide. So, E2O5 is more acidic and this is less acidic. And of the trioxides, the acidic character goes on decreasing down the group. So, when you come down the group, the acidic character of the trioxides goes on decreasing. That is, the first two trioxides are acidic, N2O3 and P2O3 are acidic. These two are amphoteric, means they behave both as acidic and basic, and Bi2O3 is purely basic. So, the acidic nature goes on decreasing. This is reaction with the oxygen. Next we will see just reaction with halogens, a little bit about this. They can use two oxidation states to form EX3, where E can be any of these elements, and EX5. For example, phosphorus trichloride and phosphorus pentachloride. But in this case, we have to remember nitrogen cannot form NCl5, because in nitrogen we have one s orbital and 3 p orbitals, total only 4 orbitals. It can form only 4 orbitals, no d orbitals in the second shell. So, because of the absence of d orbitals, it can use only s and 3 orbitals, only 4 bonds can be formed, and therefore, the maximum covalency of nitrogen in any compound is limited to 4, and it cannot form beyond 4. It cannot have compounds with the covalency 5 or 6, but all the others can show this. This I will discuss later. Next, with the metals. With the metals, all these form compounds of this formula. Example, with the calcium, you can have this is the reverse, Ca3N2 calcium nitride, calcium phosphide, or sodium arsenide, or zinc antimonide. So, in this way they can have M2, M3, N2 or any other element, E2 I can take, metal nitrides, metal phosphides, or arsenides, antimonides and bismuthides. So, these are the compounds formed when these react with the metals. So, after this we will see one more important thing which you have observed in the second period element starting from S block, group 13 and group 14. That is about any second period element in every group shows some anomalous behavior compared to the behavior of other elements in the respective group. ಅಂದರೆ ಎರಡನೇ ಪೀರಿಯಡ್ನಲ್ಲಿರುವಂತಹ ಪ್ರತಿಯೊಂದು ಮೂಲವಸ್ತುಗಳು ಆಯಾಯ ಗ್ರೂಪಿನಲ್ಲಿರುವ ಉಳಿದ ಮೂಲವಸ್ತುಗಳಿಗಿಂತ ಸ್ವಲ್ಪ ಭಿನ್ನವಾದ ವ್ಯತ್ಯಾಸವಾದ ಬಿಹೇವಿಯರನ್ನು ತೋರಿಸ್ತವೆ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ anomalous property. ನೀವು ಆಲ್ರೆಡಿ ಲಿಥಿಯಂನ ಎನಾಮಲಸ್ ಪ್ರಾಪರ್ಟಿ ಅಥವಾ ಬೆರಿಲಿಯಂ, ಆಮೇಲೆ ಬೋರಾನ್, ಕಾರ್ಬನ್ ಆಯಾಯ ಗ್ರೂಪ್ಗಳಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ. ಈಗ ವಿಲ್ ಸಿ ಅಬೌಟ್ ನೈಟ್ರೋಜನ್. ವಾಟ್ ಈಸ್ ದ ರೀಸನ್ ಫಾರ್ ಎನಾಮಲಸ್ ಪ್ರಾಪರ್ಟಿ? ದಟ್ ಈಸ್ ಡ್ಯೂ ಟು ಸ್ಮಾಲ್ ಕಾಂಪ್ಯಾಕ್ಟ್ ಸೈಜ್ ಆಫ್ ನೈಟ್ರೋಜನ್ due to which it has a high ionization enthalpy, due to which it has a very high electronegativity, and one more important thing which makes it different from others is absence of d orbitals. Absence of d orbitals. So due to all these very small size, high ionization enthalpy, high electronegativity and absence of d orbitals, due to these properties, nitrogen shows some different properties compared to other elements in the group. So we will see what are these anomalous properties. One, nitrogen is a gas and others are solids. Nitrogen is a gas and others are solids. Two, nitrogen exists as a diatomic molecule with a triple bond between this and its highly inert, very high bond enthalpy 941.4 kilojoules per mole, whereas other elements except bismuth, they are tetraatomic molecules, where here there is a triple bond, all these have only single bonds between their atoms. So this is another difference. Next, even though nitrogen molecule has very high bond enthalpy, listen here, single bond of nitrogen is weaker than the single PP or AS bonds. Single bond, as a triple bond, nitrogen is more stable than the others, but the single bond of nitrogen is weaker than this. The reason is the two lone pair electrons present on these small atoms start repelling each other and the bond becomes weaker, and therefore single bond is weaker. Then to small size and high electronegativity, nitrogen can form multiple bonds with p-pi overlapping with the other atoms of same nitrogen or oxygen or carbon. It can form multiple bonds, p-pi bonds, whereas due to bigger size and lesser electronegativity, other elements do not form multiple bonding. And then nitrogen at the maximum can have covalency of 4, whereas other elements beyond 4, that is they can exhibit 5 or 6, 5 with oxygen, 6 with normally fluorine. So they can have covalency beyond 4, whereas nitrogen limits its covalency only for 4 because of the absence of d orbitals. And then because of the absence of d orbitals, nitrogen cannot form p-pi d-pi overlapping or d-pi overlapping, whereas other elements due to the presence of d orbitals can involve in bonding involving d-pi, multiple bonds with the d-pi overlapping. So these are some of the properties of nitrogen which are quite different when we see the properties of other elements, and this is called as anomaly observed. And the reason for all these is the small size and high ionization energy, high electronegativity. So this is about the general study of group 15 elements. Next we will have some specific substances. We will study the preparation, properties and uses of nitrogen. We will see the properties, preparation and uses of nitrogen. So we call it as dinitrogen. It is a colorless, there is no color in the air, no smell, it's a non-toxic gas which is highly inert. So it is N2 and has a triple bond, 1 sigma and 2 pi bonds between the 2 nitrogen atoms, highly stable or inert. Okay. So we will study the preparation of nitrogen in different ways. So first, nitrogen is abundant in the atmosphere. So how do we separate nitrogen from the atmosphere? So from air, this can be taken as manufacture method to obtain nitrogen in a large scale from air. So first air is separated, the moisture, carbon dioxide is separated, it's made dry. Then it is liquefied. So air is liquefied at very low temperatures and then followed by fractional distillation. The temperature of the liquid air is slowly increased. Then liquid nitrogen with the boiling point 77.2 Kelvin boils out first, leaving behind liquid oxygen whose boiling point is 90 Kelvin. So liquefaction and the subsequent fractional distillation of the air will give you nitrogen which boils out at 77.2 Kelvin. What are the different methods of preparation of nitrogen in the laboratory? So second method is by the reaction between ammonium chloride in aqueous medium and sodium nitrite. So ammonium chloride and sodium nitrite when mixed, and maybe slight heating is required. First it gives ammonium nitrite and sodium chloride. So sodium chloride is one of the product, but ammonium nitrite formed decomposes to give nitrogen gas and water, and sodium chloride is the other product. So nitrogen is prepared in this way by mixing ammonium chloride and sodium nitrite. Next method, by the decomposition of ammonium dichromate. This is orange color crystal, ammonium dichromate, NH4 twice Cr2O7 on strong heating gives out nitrogen gas and water is formed and Cr2O3. So nitrogen is the product formed on strong heating of ammonium dichromate. So this reaction actually was used in the chemistry exhibition doing the experiments. The orange crystals of ammonium dichromate on heating gives sparks of light, and chromic oxide green colored mass suddenly comes out like this, and this is used for chemical volcano experiment. Normally the students do it in the chemistry exhibitions. So this is the third method. The fourth method is decomposition of barium or sodium nitrites will give you very pure nitrogen. So when we require pure nitrogen, we can heat barium nitride. On heating gives barium plus 3 N2. So these are the different methods of preparation of nitrogen in different ways. So this is about preparation. Then coming to physical properties, as you all know, it's a colorless gas, odorless, non-toxic. It is soluble in water to very less extent, 23.2 cm³ per liter of water at 273 Kelvin and 1 bar pressure. And It is diatomic molecule with very high bond enthalpy. So the bond enthalpy is 9. So you need this much of energy to break the 3 bonds between nitrogen atoms. Therefore, N2 is highly inert and present in the atmosphere along with the oxygen. Now we will see some of the chemical properties of nitrogen. Because of the stable structure, this nitrogen, it is inert, stable, does not react that easily. But if you supply heat and increase the temperature, then the bond gets weakened and nitrogen becomes active and starts reacting. So first we will see the reaction with the metals. How does nitrogen react with the metals? With the metals like lithium or magnesium, when nitrogen is added, lithium gives a very quick reaction because it is the nature of lithium, which is a very good reducing agent, or magnesium on heating, they give so we get magnesium nitride and lithium nitride. So metal nitrides are the products. Like oxides, chlorides, phosphides, we have nitrides when the metals react with the nitrogen, lithium nitride and magnesium nitride. This is reaction with the metals. Then the next reaction is with hydrogen, which is industrially a very important reaction. The preparation of ammonia by Habers process. So nitrogen gas when mixed with hydrogen, it gives ammonia. So it's a very important reaction where 46.1 kilojoules of energy per mole is given out. So nitrogen is mixed with the hydrogen in the presence of catalyst around 770 Kelvin temperature to give ammonia. Next, with the oxygen, nitrogen does not react with, do you have reaction with nitrogen and oxygen in the atmosphere? Both are present separately, they do not react. So when do they react? You have to supply that much temperature of around 2000 Kelvin to make them reactive. So above 2000 Kelvin temperature, they react to give nitric oxide. So nitric oxide is the product formed when nitrogen reacts with the oxygen. So these are some of the reactions given in your syllabus. Now coming to the uses of nitrogen. You can see nitrogen is used in the preparation of ammonia, which is used in the preparation of many fertilizers. Okay? And it is also used in the preparation of nitric oxide, oxides. So nitrogen is used in the preparation of ammonia, calcium cyanide, cyanamide, which are used as fertilizing in fertilizer industries. And because of the inert nature of nitrogen, it finds a lot of use to give inert atmosphere in metallurgy, especially in iron industries, steel industries. Inert atmosphere of nitrogen is used to stop the oxygen reacting to form oxides of the metals. And then liquid nitrogen provides a very low temperature, below 77.2 Kelvin, which is used in the storage of biological materials, also used in the storage of food materials. Some packets are sealed having liquid nitrogen is kept inside, which doesn't react, or the items do not get spoiled, the food materials. And then the low temperature provided by nitrogen is used in cryosurgeries, low temperature surgeries. These are the uses of liquid nitrogen and the gaseous nitrogen, which I have already told you.